Hi student, we have to learn group 17 and 18, then this chapter is going to finish and term 1 is going to finish today. Okay, so let us see, we have half done with the interhalogens. Now we are going to learn about interhalogen compounds. Okay, so what is interhalogen compound? Interhalogen compounds, when two different halogens react with each other, we are going to get an interhalogen compounds. So interhalogen compound, what are the types? Excess, like CLF, BRF, BRCl, like that we will get. Also X3, like CLF3. Excess means CLF3, BRF3, and ICL3 are example. Also XS5 is also two halogen. So BRF5, I5, example, AX7 type is or X7 type is IF7. So these are example. So where X is halogen of larger size and X dash of the smaller size. So first halogen should be of a larger size and second, that is highly electronegative will come second, right? And first, that is bigger one will come first and smaller one will come second in the interhalogen compounds. Okay. Now, how we can prepare it? The interhalogen compounds can be prepared by the direct combination or by the action of halogen on lower interhalogen compounds. Let us see, chlorine and fluorine when react, higher temperature, they will react and produce CLF. When chlorine and fluorine react, if we are taking equal volume, if we are taking, we will get CLF. If excess of fluorine we are taking, we will get CLF3 and it will be higher temperature. Okay. If you take equimolar, every time excess type we are getting, that is ICl. And I2Cl2. If Cl2 excess is taking, then we will get ICl3. Okay. And when bromine and fluorine diluted with water, we are going to get a BRF3. Okay. And if bromine and fluorine, when react, fluorine is excess, we are getting BRF5. So these are the method of preparation. Now, interhalogen compounds, you can see it's having lone pairs. So its shape is T-shape. CLF3 is having two lone pairs. Chlorine atom is having two lone pairs. So the lone pair, actually its structure will be trigonal bipyramidal. But because of the lone pair, they will be extending at maximum distance. That is this position. And equatorial position is actually minimum repulsion will be there if it is occupied there. So they are occupying here. If this lone pair is occupying here, more repulsion will be there. That's why they are arranged at maximum distance to avoid repulsion. And we are getting a T-shaped molecule. This is a T-shaped molecule. Okay. And IF7 is having, having a pentagonal bipyramidal shape. Okay. Shape is important. What are the uses? These compounds can be used as a non-active solvents. Interhalogen compounds are very useful fluorinating agent, and CLF3 and BRF3 are used for the production of UF6 and the enrichment of uranium-235. Okay, so these are the uses. And oxoacids of halogen is also there. Halic acid or hypohalous acid. Halic acid 1 and halic acid 3 is called a halous acid, and halic 5 acid is called a halic acid again, and then halic 7 is also there, that is called a perhalic acid. Okay, so what are example for halic 1 acid or hypohalous acid? HOS. Okay, HOF is an example. Hypofluorous acid it is, and HOCl. What is HOCl? HOCl is hypochlorous acid. So HOBr, we can use the same term, okay, hypohalous. So if it is fluorine hypofluorous acid, chlorine hypohalous acid, sorry, chlorous acid, and it is bromine hypobromous acid, and then if it is iodine hypoiodous. Oh, all the halogens are forming this halic 1 acid, okay. And what about halic 3 acid? Halic 3 acid or halous acid, only chlorine is forming one. HOCl, chlorous acid is there, okay. And halic 5 acid, that who is forming chlorine, bromine, and iodine is forming. So it is called a chloric acid, bromic acid, and iodic acid. And there is halic 6 type acid, that is perhalic acid. Again, these three are forming. That is chlorine, bromine, and iodine are forming that perchloric acid, perbromic acid, and periodic acid. These are the oxo acids of halogen. And these are the shape. Halous acid is having this bend shape. Okay, and there are chlorous acid. This is the structure of chlorous acid, chloric acid, and perchloric acid. So you have to learn how to draw it. And now group 18 elements, group 17 elements, that much is there. Now group 18 elements, we know that they are noble gas. So they won't combine because they are having 8 electrons in the outer shell. So that is one why they are called inert gases also. They have full outer shell electronic configuration except for helium. It is having 2 electrons in the outer shell. Since it is completely filled, it is called a noble gas. Okay. Group 18 elements, helium, neon, argon, krypton, xenon, and radon are group 18 elements. They are also called noble gases. What is their outer electronic configuration? Ns2, Np6, fully filled. Okay, but for helium only it is 1s2 because it has only 2 electrons in the outer shell. So they are called noble gases because they show very low chemical reactivity. Okay. Now about the occurrence. All the noble gases except radon occur in the atmosphere. Okay. So we know that if you see the atmosphere, different gases are present. We can see that there is a section for noble gases, right? 1% by volume of, see, in the atmosphere, in the dry air, 1% by volume of which argon is the major constituent. Okay, so noble gases are present 1% by volume, but among them argon is the major constituent. Helium and sometimes neon are found in minerals of radioactive origin, pitchblende, monazite, cleavate, etc. The main commercial source of helium is natural gas, and xenon and radon are the rarest element of the group. Radium is obtained as a decay product of radium. Okay, so these are about the occurrence. Just understand. Next we can go to the electronic configuration. We know that the outer electronic configuration is Ns2, Np6. All are completely filled. Okay. And what about the periodic properties like ionization and enthalpy? Stable electronic configuration, these gas exhibit very high ionization enthalpy because it is already stable. Removal of 1 electron from the outer shell is very difficult. You have to input high energy. But when we are moving down, what will happen? Ionization energy decreases because the size of the atoms are increasing. So the electron, nuclear charge exerting on the outer electron will decrease and it will be easy to remove the electron. Now, what about atomic radius? It will be increasing down the group because the number of shell is increasing. What about the electron gain enthalpy? Noble gases have stable electronic configuration. We know that they have no tendency to accept electron. Also, removal of electron is also difficult. So, have large positive value of electron gain enthalpy because of that. Okay. Now, what are the physical property? They are monoatomic. The atomicity is 1 because they are not going to combine. They are colorless, odorless, tasteless, and they are sparingly soluble in water. Helium is very light also. They have very low melting and boiling point because the only type of intermolecular attraction is the dispersion force. And helium has the lowest boiling point of any known substances. It has an unusual property of diffusing through most commonly used laboratory materials such as rubber, glass, or plastic. Okay. And what are the chemical properties? In general, noble gases are least reactive. Their inertness to chemical reactivity is attributed to the following reason. Why they are inert? Okay. The noble gases except helium have completely filled the electronic configuration in their valence shell. They have high ionization enthalpy and more positive electron enthalpy. And because of that, they are actually rarely reactive. The reactivity of noble gases has been investigated occasionally ever since their discovery, but all attempts to force them to react to form the compound were unsuccessful. But Now we know that some compounds of noble gases are also possible, made it. Now chemical properties, compound of inert gases, that is possible some extent, okay. So first he prepared a red compound which is formulated as O2PtF6 minus. This is first prepared the University of British Columbia observed the reaction of a noble gases. So first he prepared a red compound which is formulated as O2PtF6 minus. He then released that the first ionization enthalpy of molecular oxygen was almost identical with that of xenon. Okay, so he made effort to prepare same type of compound with the xenon. So this is not a compound with the noble gas, but the oxygen and the xenon in this compound is behaving in the same manner. So he tried to prepare a xenon compound using this. Okay, so xenon compound he prepared. Red color compound of XCPtF6 is made, minus is made in the laboratory by mixing PtF6 and xenon. Okay. And the compound of krypton or fever, only the difluoride has been studied in detail, KrF2. Compound of randon have not been isolated, but only identified RnF2 by radioactive tracer technique. No true compound of argon. Actually, their size are very less, and it will be difficult to. We are moving down, the ionization is increasing actually. Because of that only, the higher members actually react with the some elements, but they cannot react because its size is very small, and it will be very difficult to remove electron from it. What are the uses? Helium is a non-inflammable and light gas. Hence, it is used in filling balloon for metallurgical observation. It is also used in gas cooler, nuclear reactor. Liquid helium find use as cryogenic agent for carrying out various experiments at low temperatures. It is used to produce and sustain powerful superconducting magnets, which form an essential part of modern NMR spectrometer and magnetic resonance imaging system for clinical diagnosis. And it is used as a diluent for oxygen in modern living apparatus because of its very low solubility in water. Okay, that's all. Thank you.